Okay, we're going to get started here. Seems to be a fair number of people taken away. I'll assume it's probably because of other assignments and obligations this time here. So today's topic is going to be a process that occupies much of your time when building programs. It probably already has in this course, and it will through the balance of the program. And that's the topic of debugging. Locating the faults that lie behind observed failures in programs. So before we begin, I just want to make a few announcements. First, I was asked to emphasize to the class the course evaluations are currently online. You can go and fill them out, and I strongly encourage you to do so. It's one of the most important ways we receive feedback about a course, good or bad, and can help us refine that course further, know what's working, know what needs refinement. Turns out they're only available till Monday. I didn't know this, but they stop even before the term starts. And I did check, and it seems that the response rate for this class is still really low. So if I can, I'll try to stop a few minutes early today, so those of you who have mobile devices or laptops could pull them out while still in class. But in any case, I'd urge you to do so. This is the last meeting of the class prior to the new date for the course evaluation, so I won't be able to exhort you further. That's another occasion. Well, excuse me, Monday, okay. Remember, we have the review session on Monday, 4 p.m., and I can exhort those who come to the review session, but some may be left enough to do so. Instead, you need on YouTube. And please do try to remember to fill out those course evaluations. They are important. What's this, assignment 2? Let's say assignment 3. I've been getting questions about assignment 3, various issues with it. And one I wanted to highlight is that this assignment is a little bit broader than assignment, the component of assignment 2 that dealt with the same system. That was more absolutely contained. And here you're filling out pieces of a system, and there may be some things in that system, for example, constants, which are commented on in the specification of some of the functions, which you need to define, which aren't yet defined for you. So you will need to do some filling in pieces. There may also be some components of the code that is given to you, which includes where you get warnings on it, and you may have to go and fix those up. Okay. So just bear in mind that part of the design of this is to let you sort of fill out the balance of the program. So there are some things to fill in this to be expected in this case. So Lab 11 also had some questions associated with it. There are specifically, it seems, some confusions among people in the lab related to resolving these clashes between changes, which I've asked you to undertake in problem 2 of Lab 11. So those who have started it will know that problem 2 of Lab 11 involves a step-by-step examination of a case where there's a conflict in 2 changes. You're undertaking both those sets of changes, but you're sort of simulating a situation where there's some set of changes undertaken by developer A and another set of changes undertaken by developer B. And you're going, sort of rehearsing as it were, going through an exercise which lets you see what would happen, you know, if one of the developers checks in the changes before the other, which has to occur. Subversion is a check is atomic there, and it either occurs fully and all at once or not at all. So one of those people will essentially commit their code before the other. If they do it at just about the same time, one of them will be preferred. conflict. And there was a question about, well, in class there was this discussion about when there's a conflict, you have a commit, there's a conflict, that you should be able to see the code from both sides. See your own code and see the code that was already there in the repository, and see the code, in fact, before either of those sets of changes took place, kind of the root code, the code that predated both of those, and in fact one file where you can see both. This is true. And I just wanted to remind people as to where that occurs. So when we have a commit in this compile-modify merge strategy, the commit can fail. And the error message with Subversion is that the file is out of date, which is a little bit confusing, but basically it means, hey, you're operating off a revision. Carrie here is operating off a revision that's not the revision that's in the Subversion repository now. Sal has already checked hers in. So his version is not the version that's in the head of the repository. It's not doesn't reflect the latest state of the repository. In that sense, it's out of date. So what has to happen, ladies and gentlemen, before Harry gets to see those files, which tells him what Sally contributed and lets him see the difference between what he did and what Sally did? What has to happen before he can see that information? You have to do an update. You have to do an update. Commit itself, we'll just say, on an A, and you then subsequently, and it's a little bit confusing, I must say, subsequently have to do an update. And you'll notice that, oops, that was highlighted there, SVN update. And it's at that point that it will go place all the requisite files here for him to sort out these 4 files. And that's actually if you choose a particular option of it. I think it's the P option for postpone. That's when it puts down these different files. There are several options you can choose in response to that. I believe this is called the P option for these. You can postpone the compile. Let me figure it out. Let me choose after some deliberation, after some further refinement in terms of merging the changes. Only then actually finish the job. There is an option, for example, when you say this, to choose that I just want to preserve my changes, my current changes. Sally's changes, forget them. I'm just going to preserve mine. That's another option. Alternatively, you can prefer her changes and forget about yours. In this case, it's the P option that gives you these different choices. Okay? So you do have to do this SVN update. And how does it magically know? It may seem automatic. How does it know that it needs to create that, when you do an SVN update, that something is off and it needs to give you this choice? Well, it turns out when you did that commit, it retained some information about that. Commit said, hey, out of date, and it actually remembers there's a conflict after that. And so when you do the SVN update, okay, I know there's a conflict with this file, so I need to present the user with a set of choices, and one of the options is to create this file. Is that okay? People okay with that? Good. Questions? Okay. So that was an issue on lab 11. There was another issue that related to lab 10 that I just wanted to try to highlight. And I'm grateful for you folks bringing these things to my attention. So the issue there was with GDB. So in GDB, GDB is an extremely powerful system. You can use it in a very flexible way to inspect what's going on in the internals of a program. You can set breakpoints so that the program breaks in a specific place in the program. You can set watch points such that when a certain variable changes, a certain element of the array changes, it will stop. alert you to that fact, and let you then do something at that position. You can set conditional breakpoints where, hey, you want it to stop at this position under these conditions. So once the value of I in the loop reaches 100, stop here. You can get it so that when it does stop, it undertakes some commands and then continues. Sort of robotically sort of prints out information that you're in which you're interested at that place. There's many powerful things you can do. One of the things that students sometimes miss is that within GDB's command syntax, there's a great deal of flexibility allowed. So you folks will already have used some of the basic commands, things like step, things like next, that whole select frame command, for example. You also will have done backtrace, for example, to see the call stack, etc. And finally, one of the most useful elements is print. Print is extremely useful for the debugging process we're going to be talking about today. Finding infected states of a program. Where did the series of events that precipitated, that led to this failure that was observed, where did those come from? Where did the error first come in? Where were things first not sane? What did that affect in the program? So you use print to sort of interactively examine things. It's great. So you folks will have done things like print A, maybe you would have seen print star A, something like that. One thing you should realize is that this argument to print is a general C expression. You can actually get GDB to call functions in the program, interactively. And you can put here a very, general expression, print I plus 10 divided by B or something like that. You can, moreover, print quite articulated expressions like a dash and a greater than sign, of course, meaning we're accessing fields in this. Next and then go to payload or something like that. So if we have a linked list and P points to a linked list, we might say, okay, get a pointer to the next element of the linked list, and then get a pointer to the next element yet, and then show me the payload, the sort of piece of data that's stored at that point in the linked list. So if we had here something like this, and we have P pointing here, there's some sort of payload here. Maybe it stores an integer, or it stores a double, or it stores a whole pointer to a structure or something like that. And then there's a next pointer here, and points to next. And so we had P pointing to this first one. We might be able to go down here. This is the payload, and we might be able to, access the payload for this guy by this sort of expression. So GDB allows you to insert more or less arbitrary C expressions when you interrogate it, print it. Or if you have a breakpoint, you want to make it conditional on a certain expression, you can put in a very general C expression. So it's not merely that it puts you in a straitjacket of certain rigid things. It can print a variable, and it's expecting a variable name. Or it can print to a star and then variable. No, it's actually, it has a lot of latitude. It parses C expressions and handles it. Okay. So that's a useful sort of factoid to keep in mind, to bear in mind with you. Okay? So that was the question on latitude. Any questions that I should answer further right now? I know it's a busy time of the semester. I'm going to try to set up another extra. I know I have to review on Monday. I have a office hours, my last formal office hours of Tuesday. Another class I'm going to try to set up an extra office hours late next week also for some small stuff. Okay? Any other questions? Okay, so nothing right now. We're going to get into debugging. Now, this topic may